Well, things are starting to get a bit more complex. Fractions. We've been talking about fraction operations. Well, now we get to do order of operations with fractions. We're going to start to see some algebraic expressions that need to be simplified that have fractions in them, but there's more than one operation to do. So just like we did before, we have to follow the proper order. And if you recall, I gave you a new order to follow, right? Grouping, exponents, multiplicative operations, and additive operations, GEMA. So those are still going to be there. Those are going to be the same operations, the same order we have to follow, whether it's fractions, whole numbers, integers, whatever. So we only need to really look at a couple here. Because we've done this already, it's just going to give us an opportunity to practice more work with fractions. So simplify. That's going to be your instruction. Simplify. So 1 over x times 3/7 minus 1/7 divided by 1/2. So pause, try it, see what you can do, and then come back. So when I look at this, I see 3 operations, times, minus, divide. So the multiplication and division fall into the multiplicative operations, and the subtraction falls in the additive operations. So I have to do this one first, then I'll do this one, and then I'll take those two results and I'll subtract them. So let's start with this first one, 1 over x times 3 over 7. The best way to do a problem when there are multiple operations is to do some side work. Jot the part of the problem down over here that you're going to do, so you can only focus on that part. Use this space to record and organize your information. 1 over x times 3 over 7. Well, that's going to be 1 times 3 is 3. X times 7, generally we put the number first, is 7 over x. So that's it for this part. This is it is 3 over 7x. 3 over 7x. I'm going to just write the rest of the problem. 1/7 divided by 1/2. So now I'm going to do this other part, right? This division part. This right here, this sign is minus. So it's almost as if there are parentheses grouping that part of the problem together. Okay, so I'm just going to focus on this part. We have 1/7 divided by 1/2. Well, there's fraction division. We change it to 1/7 times the reciprocal, 2 over 1. Multiply straight across because there's nothing that can cancel, and you get 2/7. So let's rewrite the problem. We bring down the 3 over 7x minus, and then we have 2/7. All right, we're getting closer. We've got 2 operations down, 1 to go. So now it's subtraction. Think subtraction with fractions. The denominators must be the same. They're not the same right now. So I'm looking at this first fraction, and I think, well, this has a 7 and an x. 7 times x. This one has a 7. These factors are the same. But this fraction, this denominator has an x, and this one doesn't. So we're going to share it. We're going to share that x over here, and we do the same thing to the numerator. So now I'm going to rewrite it again in the new format, 3 over 7x minus 2x over 7x. We've finally gotten to a spot where we have common denominators, so now we can merge them into one fraction, all over 7x, but careful with the top, because the numerators are not like terms, so we can't actually put them into one term. We have to leave them separate. 3 minus 2x over 7x. That's as far as we can go. This original expression, when we simplify it all the way, is equal to 3 minus 2x over 7x. And no, there's nothing you can simplify from there. As we said before, you can't cancel, like the x's, you can't cancel part of an addition or subtraction problem. You can only cancel when it's all multiplication. All right, let's try one more. Again, pause this and try it. So in parentheses, we have x over 3 minus x over 11, parentheses, more parentheses, times 1 minus 1/2, in parentheses, I'll say quantity, squared. So take a look at that, pause, and try this. So what I notice here is that we have two sets of grouping symbols. We have parenthesis here, and we have a total separate parenthesis there. So we can work those two things independently. I'm going to start with the first one. X over 3 minus x over 11. The denominators are not the same. We need to get them the same. They are both prime numbers, so I can't factor them. Basically, this has a 3. This needs 1. So I'm going to multiply this by 3 and this by 3. This fraction has an 11. This needs 1. So multiply these both by 11. When we do that, it's going to give us 11x over 33 minus 3x over 33. So that's what this is going to turn into just from getting common denominators. So I'm going to rewrite it here. It's kind of my first step, right, in organizing all my information. And I'm going to finish this off. This subtraction here, they've got the denominators the same, so we can merge them into one fraction. 11x minus 3x is 8x. They are like terms. They are like terms, so we can keep them, where we can merge them into one term. So this part's done. Now let's do this one. 1 minus 1/2 x. I'm going to go to my side work again. 1 minus 1/2. Sorry, there was no x. 1 minus 1/2. Well, I need to subtract fractions. This is a problem you might just be able to do if you picture a circle, right? And what's happening. I'm going to work out mathematically, algebraically, procedurally what you might do. You might start by putting your whole number over 1. That's always something you can do when you're working with a whole number and a fraction. Then we say, well, this has a 2 in the denominator. This doesn't. So we can multiply this by 2 and this by 2. Remember how we can write the number 1 always as some number over itself? And if this has a denominator of 2, we want this to have a denominator of 2. 2 halves minus 1/2 is equal to 1/2. So this thing becomes 1/2. 1 minus 1/2 is 1/2 squared. All right, so far so good. Now I have to square 1/2. Be careful with this one. When you square something, it means you multiply it by itself. This is one that's frequently missed, mostly because we don't really think enough about it. 1/2 times 1/2 means 1/2 times 1/2. 1 times 1 is 1. 2 times 2 is 4. The most common error on that is people they add all the numbers instead of multiplying them. They put 2/4, which is really the same thing as 1/2. 1/2 squared is 1/2 times 1/2, which is 1/4. So that's what we put here. Okay, so remember when we have parentheses sets next to each other, it means multiplication. That's what's going to happen now. Now, we can multiply fractions whether they're in parentheses or whether there's the little dot. So maybe you would kind of have the idea what to do next better if it was written like this. This notation means the same thing. Parentheses, dot, both mean multiplication. So now I'm going to look to cancel while I do my multiplication. So 8x, if I factor it, is 2 times 2 times 2 times x. 33 is 3 times 11 times 1/4 is 1 over 4 is 2 times 2. Now maybe some of you are catching some shortcuts you could take at this point. I still like working it out like this because I feel it's that important. We cancel, and we can cancel because it's multiplication. I'm going to say that 1,000 times. 2 cancels with 2. 2 cancels with 2. That's all the cancellation that can happen. And now finally, we multiply everything together. That's still there. 2 times x times 1 is a 2x on top. 3 times 11 is 33 on the bottom. And we are done. So, a couple very different problems. The order stays the same. Grouping, exponents, multiplicative operations, additive operations. We just have to keep the fraction work. It works the same way, right? We keep I like working the fraction work off to the side, organize some information on the left, do some side work on the right, and then that keeps everything organized and laid out in the proper